Now let us continue with the IC fabrication 2 part 2. So let us review a little bit on metallization that we left in the part 1. Okay, so metallization procedure done to provide electrical connection between the IC devices. So for example, once we already prepare all the part here, it is need to be connected in order for us to connect it to the circuit. Okay, so for the aluminum deposition, it can be performed in several methods. For example, evaporation, sputtering, chemical vapor deposition, ion beam deposition. Okay, so then photoresist coating, and then we do the pattern photoresist. For example, in the process involve masking, photolithography, resist development, and many more. And then we perform the etch of the metallization, aluminum etch using reactive ion etching, RI, or dry etch. So this one we are going to learn further on etching topic later. And finally, it is a completed process. So etching, as I mentioned, will be a whole different subtopic that can be discussed in separate lecture. Sputtering is the most common process that used in the microfabrication for the metallized layer. Okay, so what is the process of the sputtering? It is a process where the aluminum target material. Okay, so in here you will see this is cathode. Okay, this cathode is aluminum in material. So what happened is the argon gas is used as the plasma, which is the ionized ion, and then it is sputtered towards the cathode, which is the aluminum, and then it make the aluminum ion to be bounce and then goes into the anode. Okay, so this Ar plus ion bombard Al target, causing aluminium to be deposited in many different angles. Okay, so then it can go to the Si wafer layer. If the process is already completed, and then the next step that we have to do is the wafer inspection. So there are two types. One is visual inspection and another one is chip test. So for visual inspection, it is to look whether the physical abnormalities that indicate the damage, or this one can be performed via automatic imaging and inspection system, because we cannot see it using your eyes, right? So it has to be performed automatically in imaging process. Okay, so the next one is chip test. So wafer will contain which contain many individual integrated circuit chip will go through the testing, where each chip will be tested. Okay, so for probe send and measure signal response, so it is done automatically. Okay, and the failed chip will be marked and discarded after the dicing. So if you look into this example, so each of the chip will become one separate things, right? So what happened is the computerized machine devices will test each of the what we call the circuit, the individual integrated circuit chip here, and then if it is fail, then it will create like a dot on it, so that it will be discarded after the dicing process. Once the inspection is already done, the individual chip are cut from the wafer using a diamond saw. Okay, so this is the diamond saw, so it will cut through the wafer. The wafer to be cut is adheres to a mounting film and saw. Okay, so in order to protect the part, it will be they will use the mounting film. Okay, so each dice chip is called die. Okay, so this one small thing is called die. So after the dice is already diced, the most important thing is for us to do the mounting. Because of the small size of the die, we have to protect the die, and also we have to make it easier for us to attach it to the circuit, to the like the motherboard. Okay, so when we do we in order to do mounting, for example, the first one is the process of die bond. We can use die bond process to perform the mounting. So the die bond is where the die is bonded into the ceramic or plastic base coated with gold or aluminium or silver paste. Okay, so this one, the lead frame also fitted to the base. Okay, so this is the base. Okay, so if you look, this is the base, and on top there will be a lead frame. Okay, so and the lead frame on the middle here there will be island. Okay, so what happened is on this island they will place the silver paste, and then where the heating and melting process take place, and then we put the IC on top of it. Okay, so this is the process of the reflow soldering. Okay, then the chip will be placed on top of this area. So as for the lead frame, there are many type of architecture and pattern of the lead frame. So this is depend on the function and also the what we call the needs of the IC. Okay, so then it is designed accordingly. The next process that we can use to bond the die to the island there is through wire bond. Okay, so each bonding pad on the die is connected to a corresponding lead frame with a thin gold wire. Okay, so what happened is, for example, this is over here is the circuit, the IC. Okay, so there will be a gold wire that will be connected to the lead frame, okay, one by one, okay, on this one. The next process that we're going to look into is flip chip. Okay, so previously we already see the wire bond, right? So flip chip is the modern alternative to the wire bond. So wire bond is the old technology. So flip chip is the latest one. So where the small dot of solder will be deposited on each bonding pad, and then the die will be flipped with the IC facing down, and then it will place on this area. Okay, when the solder is contacted to each other like this one, then they will do the remelting using the ultrasonic or reflow solder method, so that it can produce electrical connection. So then both area will be collected. Okay, so this one, all of them will be connected. So the problem that may arise in this process will be what we call when the flip chip configuration to the SI die substrate due to the coefficient of thermal expansion is different. Okay, so the CTE, okay, then uh, what will happen is high thermal stress may cause board warping failure during operation. Okay, so in order to solve this process, the encapsulating epoxy with CTE value between the die and frame will be placed. Okay, so this is the epoxy. They place the epoxy to in order to balance between the coefficient of thermal expansion between the two material. Okay. So usually the flip chip is much better for from the wire bonding. Okay, so why the flip chip is better than wire bonding? The first one is better connection. Where wire usually will add extra capacitance and inductance, so it will limit the signal speed. But for the flip chip, it can be faster production and also a small average package, meaning the area we don't really need a big area compared to the wire bonding. So wire will require space at extra lengths, and therefore we need a bigger area for the chip. So let's see the overall packaging process. Currently, the most widely used packaging type is the ceramic dual inline package, or the short form is CERDIP. Okay, so for this one, the lid frame fitted on the glass glaze region of bottom ceramic. Okay, so this is the glass glaze material. Okay, so bottom ceramic. Okay, so then uh, it will be the mounting process. Okay, so then we do the mounting, and then there will be a wire bonding process. Okay, so or a flip chip. Okay, and then top cover fitted. So the process is we cover the chip. Okay, the top cover fitted, and then trimming of extra lid frame part if required. Okay. So here are some example of the micro manufactured IC products. So I believe that many of us have seen this kind of chip in our computer, in our handphone. Okay, so these are how the chip has been um, produced. Do you think the IC fabrication process is completed? No, it is not. Okay, so it's far yet to be finished. This process will be continued in our next lecture. So at least we end our class today. Okay, so we are going to continue our lecture in the next class. Okay, Assalamualaikum. Thank you for listening.